Yes, my name is Michael Schaefer. I'm working in Thales, Germany since more than 25 years now, and I want to talk a little bit about the usage of Capella we used in the bid phase of a project. So you see afterwards the reasons why we started already in the bid phase, not only in the execution phase of the project to work with Capella. But before I start, I will start a little bit to explain a little bit about myself. I'm working as lead system architect, and Stefan already introduced me a little bit on my history here in Thales, Deutschland, in Ditzingen. And Stefan, you pronounced it very well for a French guy, so this is quite good. And you see here my email address if you want to contact me afterwards. And you see also on this picture that I'm interested not only in the signaling and in modeling, but also privately railways are things I like very much. And so I'm interested in bringing new technology, new ideas also in the railway business today and tomorrow. So for this presentation, I first want to look at what are typical problems we have in the bid phase of great projects. Like you see in the next step here in the example of a railway traffic management system. We will have a look what is a railway traffic management system, why we need to introduce new topics there, and what are the challenges in this business now. And at the end, we will have a look, how does Capella help here? What did we do there? And what are the benefits for using Capella also in such a phase? And starting at the beginning of a big project. So you see on the top right corner, this presentation was originally done for the Capella Day here in Stuttgart, but we agreed that it might be interesting for several other people who could not participate at the Capella Day here. So I will show it to you, and also in a little bit more deep detail, a little bit more than I showed on the Capella Day, because we have a little bit more time now. So maybe also guys who were at the Capella Day might learn a little bit new about our problems and our ideas how we could solve this. Yeah, what are the problems we saw in bid phases, like the guy who wants to set up this puzzle here at the moment? One typical problem we see is the problem of different languages. This does not only mean that we have to work as German guys in projects which have only an English or a French bid documentation, but we are also faced with the problem that in our domain, in our railway domain, different countries, different operating companies speak different languages, even if they are using the same kind of railway locomotives, railway tracks, railway stations. But for example, the simple term station you use has a very different meaning if you are talking to a German railway guy or a British railway guy. And sometimes even if they are speaking the same language, an American guy, an American railway staff could have a very different opinion about several topics, several things in the railway business than a British guy. One next topic is we find often in bids very inhomogeneous technical figures. Bids are often done by not so deeply technical involved people, so PowerPoint presentations, PowerPoint figures are often used as basic architectural drawings. If you have some guys who are coming and working from a development department, you often find Visio drawings there, but they are often not looking very much the same style, and they are often also using different terminologies, because maybe people coming from different countries and, as we saw, coming from different languages there. Both things lead to misunderstandings inside the bid team, that people think other people mean different things, but they do mean the same or the other way around. And it leads also to misunderstandings between the bid team and the customer on the other side, because the bid team does not really understand the technical problem in the background. And the different languages and the inhomogeneous technical figures lead also to the problem of poor documentation and poor presentation in the different documents. You will see later on a further slide some examples of one bid documentation we made 1 year ago. And you will see also how at the end Capella may help there. So you see, this is a lot of things we have to cover, we have to work on, and I will show now how this could work. Has anybody lost the sound?
No, everything is good.
Okay, everything is working. So sorry, because I saw some message that somebody has lost the sound. But so I will try to continue simply.
If someone has lost the sound, please send me, Stéphane Bonnet, a message.
Okay, then I will continue now. I want to show the example of a traffic management system. So one typical question is, what is a traffic management system in the railway business? You see here a simple example of a railway line. A traffic management system is a system you see here which can local and global manage railway traffic. So this is an interesting sentence, but I will help you a little bit to enlighten you what this means. You see on the left side on this slide here a young lady working in a signal box. I think it's from the time of the First World War, so it's about 100 years ago. But don't forget, there are many such interlocking, such signal boxes in Europe today working at this principle. So this is nothing new and nothing uncommon also in today's operation. But railway operating companies want to come from this local operation to a global management on the railway traffic network you see on the right side. But never forget, railway operating companies have a long history, and it's often difficult to change their operating principles. So we are typically faced as a company providing such railway traffic management systems with the requirements that on one hand, the customer wants to have a local operation, not with such mechanical levers like you see on the left side, but with a notebook or a tablet, a working gang, working staff that is working outside at the railway track can use to operate locally the railway traffic there. But on the other hand, they do not want to have only this local operation, but they want to have a global traffic management system. For example, the question arises if an operator who is working in, take for example, Hamburg in the northern part of Germany, if he decides to stop a train and let a different train with higher priority, like a TGV or an ICE, pass a freight train, what happens when this freight train will 10 hours later arrive, for example, in the Munich area in the south of Germany? Will it then disturb the traffic there if it arrives half an hour later? What happens there? Will other trains be affected by this problem? So these are often questions railway operators ask, and they want to have a traffic management system that allows on one hand the local operation, but on the other hand they want to have exactly those answers to those questions that helps them to operate their traffic, their railway traffic, in the best way. The best way means less delays of trains, less energy consumptions, and all such parameters which can affect railway operation. So a modern railway traffic management has to provide both. On one hand, a local operation possibility, which mobile devices with flexible devices, and on the other hand, a global management system, a global optimization system for the whole railway traffic in the country. One typical example we had in the last 2 years, we had to prepare an offer for such a project for the Norwegian railway company. The Norwegian railway company, or the so-called Bane Nor, who provides the railway infrastructure there in Norway, manages about 4,000 kilometers of railway networks. This is not so big in Europe. Countries like Germany or France have networks about 30,000 kilometers railways. But in Norway, we are faced with a situation which is not so uncommon, but not always typical for all European countries. We are faced with a situation with a very heterogeneous traffic there. We have, for example, in the area of Trondheim, more in the north or the middle part of Norway, only a few trains per day, about 60 trains per day that have to be controlled there. But we have in the area of Oslo, where we have a large density, more people living there, we have about 1,000 trains per day, which are more common in other areas of Europe, like in Paris or in Berlin, for example, there. So we are faced with a situation that we have to provide traffic management that finds the optimum solution for such heterogeneous traffic situation. We are coped with the situation that we have to provide at the end 3 control centers, and we have to cope with the situation there that the customer has existing legacy signaling boxes, interlocking systems there, and that we have to connect and to adapt to those legacy signaling systems there. So we saw the term, here, I just forgot to mention it. So you see Trondheim is this area here in the middle part of Norway, and the Oslo area. You see the dense network. This were only the examples for the 2 different situations for the different train traffic density. This is a picture you just saw on the slide before, that we have to provide 3 control centers, and this is a picture from a typical control center we deliver. So we deliver working places, operator places, where operators can control their local traffic, their area there, but we have also often to present in the background, you see it here, a huge overview screen providing the overview over a whole area or a whole network. You see here, for example, a network where we control 2,400 kilometers of railway network already in Saudi Arabia, where mineral and freight trains are traveling from mines inside the country towards the coast, where the minerals could be put in a port and put there onto the ship. So we are faced with the problem that we have to put in operation such control centers, 3 types there in Norway. And 2 years ago, we started there with an offer for this project. And if you look at what we presented in the documents 2 years ago, this was the first round of the offer. The customer there decided, okay, we make this bid process in 2 rounds, in two stages. In the first stage, every provider, every company who wants to offer a system there can present their documentation. Then we give feedback, and then we can make a best and final offer in the second round and try to find the company which provides the best solution. And you see here some example figures coming from our offer documents in the first round. If you take a closer look, you may see that some parts are Visio figures, more on the left side. Some parts on the right side are more PowerPoint-like figures. And if you have a closer look, you see that they are very, very different. You see different colors, not used in a unique way, different names, sometimes for the same components, different representations. You see computer-like equipment on the left side. You see boxes on the right side. And if you are looking quite deeper into the system, you will find much more differences inside there. And what you also see is you have mixed representations. A typical example is the figure on the right side. It's a mix of a logical and a physical view. You see sometimes aspects like this green frame here, which represents a network, a physical component, but inside you see some boxes which do not represent physical components like nodes or computers, but logical architecture components that represent logical parts of the system there. And what you see also are mixed views from a technical or more sales-oriented point of view. You see on the right side a figure that shows a more technical view to give the reader an impression which systems are connected via which media. And you see on the left side, for example, here on the top, a more, I would say, sales-oriented figure that shows that our systems are separated via firewalls from the open network, but it has no real deep technical knowledge. So we got back an answer from our customer after this first part of the offer that he quite understands our architecture, but that it's not looking very much state-of-the-art. So we decided then in the second offer to change the architecture of the system in the background. You will see this later on in some slides, but also to change the approach, how to document and how to present this to the customer. This here, for example, I remembered that I forgot to mention something here. This is an example of what I mentioned before in some slides of a poor presentation. It looks on the first view quite well if you have only one document in front of you, but if you compare the different documents where those pictures are coming from, and this has been done by the customer there, you see quite well that this is much more looking like you did documentation 20 years ago, but not as a state-of-the-art. So, in the next slide, I want to show you a little bit what changes in the system if we started the usage of Capella there. You see already in the background the slide, and you see that it looks a little bit common like you see on the slides before, but I will show the difference. What did we do different concerning the modeling of the architecture? You see now on the left side a figure that looks quite similar to the figure we saw 2 slides before, but it's different. It's coming from the logical architecture model of the Capella model. So you see now it's not a mixture anymore of logical and physical aspects, but it's showing only the clear separation of the different subsystems of a TMS, an HMI system on top serving the HMI for the different users you see in the control centers, a bus subsystem, something like an enterprise service bus managing all the connections, the core TMS application system, a new platform concept that serves as a basis for the application, and an interface subsystem connecting the legacy and the new signaling systems there. And this is clearly separated from the physical architecture on the right side, where you see now the connections directly used in the system. You see network components in yellow here. You see in green all those components the customer has to provide to us. And you see the different server and working place components. And it was quite interesting for me that in this project, in this big project, nobody has just seen before that we do not have a complete view on the physical architecture before. So this was one of my major aha effects, I would say in German. These things where I said, oh, I learned something new. It helps you also in the bid phase very, very much to do only a rough, at least rough, logical and physical architecture in Capella to see what is missing there. Often, sometimes, small parts are only missing, but it helps you a lot if you have a real clear view on both sides of the architecture, the logical as well as the physical, to identify missing elements there. What we did also, but I will not show it here in the presentation, we do a mapping of these components here and the subcomponents to the different server systems, and you will see on the next slide, this is an example. We did also a functional allocation here on the logical level to the different components, and we do this for critical scenarios. So especially those topics inside the systems where we have to connect to legacy systems, where we want to explain our customer more in detail how this works. He requested this for, he called this critical scenarios, to get a deep information about how we will implement this during the project phase. And for this, it helps us very, very much to do this in discussion with the customer. You see also here, to explain it a little bit better, we sometimes repainted the figures. We used some special viewpoints partly for this project to get different colors for different things there, to explain this to the customer in a better way. We also used the standard coloring of Capella, but at some point in time it was quite an advantage for us to do it in a different color, to explain, for example, to the customer simply, you see this here on the bottom left part in this darker blue part, that these things are belonging to a different logical component than this top one, so but they are belonging closely together to one component group, so they could be colored in one color here to express this quite better. Yeah, coming a little bit to the conclusion, you saw some of the pictures we had there, and what do we see as advantages for the bit phase? We see it enables us to have a common view on the architecture. You saw in the first bit phase we had separate questions, we had separate views on the same system, which have quite a different look, which have quite a different look and feel, and it was for us an important thing to have as a bit team a common view on the architecture. It helps, so it's written here as a co-engineering enabler, it helps us to work together as bit team, as developers in the bit team, helping the bit team to support them with new ideas, with new architectures. It helped us to develop also a new architectural approach, which we try to start now. And it helps also to work together with the customer, to give him the feeling and to give him the idea that we really understand what he wants at the end. It has also some simple advantages. We have same figures, same look and feel in multiple documents. So our documents looks much better in the second approach. And sometimes the customer said, now your system and your documents do not look like the systems coming from the 1970s of the last century there. So also from my point of view, do not underestimate a good look and feel of your documentation, which is sometimes much easier to achieve with a common modeling tool there. And last but not least, it has the advantage we have a unique naming on the figures. If we decide to rename one or two elements in different views, they are already renamed in the other views too. Yeah, I already mentioned it was important for us to use both the logical and the physical view. We could easily identify missing topics there, and we used also, and this was one advantage for us, the automatic colorization by a specific viewpoint, which helps us to reduce the manual effort to put corresponding and correct colors in each of these figures. But nevertheless, last but not least, we have also some challenges. Surely for people working in a bit team, you need to know, you need some time to introduce this method in the bit team. So it's not easy. You see here on the last line, not everybody in the bit team likes, oh, this is yet another tool and yet another method here. So there are questions, where is my PowerPoint? Or couldn't you change this figure not in the way that it looks like a PowerPoint figure? So you have to cope with this problem, and you have to see that you need time and surely also money for introducing this method, not only in the development, but also in the bit area. And we discovered this also here in this bit. We didn't have enough time to complete the explicit functional breakdown. We did it partially at some points which were critical for us, but for the whole system, it was started before we decided to use Capella here. It was started to be done in Visio, and we completed it there in Visio. But surely we agree that it's better than nothing. So if there is a possibility to use some drawing tools like Visio, it's better than nothing, and better say, okay, this will be done later in the real development phase. So the allocation to the components from the functional breakdown is surely missing. So this is one thing we have to do now in the final phase of the project. Yeah, these were some of the experiences we had, but from my point of view, it was quite well to do. It works quite well in the bit team, because we were at the end very used to look at all these Capella figures and to see and to check what is possible there, and to have one common look and feel and one common approach to the system. Yeah, my last slide. This is really the result. We won at the end of the bid there in Norway. So we have to implement now the system there, the TMS there in Norway. And this is quite a challenge for us, because we do not have only to use Capella there. We also have to use to provide now a new system with a new architecture. But we have now a basis. We have a basis for the development there. We can reuse this model, and we will do this in the development, where we do now the complete functional breakdown, where we provide functional chains, where we provide the basic specification for our development team. Yeah, and last but not least, and this is also an important thing we saw in the company now, the acceptance of Capella grows. It's now not only some exotic new modeling tool of the system engineers. It's also a tool where many people who were before just afraid, oh, new tool, I want to get back my Visio, where people said, oh, we can do a lot with it. We can see that there is a good way to separate logical and physical architecture. So from my point of view, it was quite challenging, but at the end we were successful and we won the bid, and we were happy to continue the development now and to start now the real project based on what we did during the bid phase, also with Capella. So thanks for your listening. If you have any questions, we can answer this now. And this is just the end of my the final end of my presentation.
Okay, thank you, Michael. I'm trying to see whether I received questions in the chat. I don't see them, but I get them. So, okay, it was sent privately to the host. This is why. Okay, first question is, what was the approach to learning? Tutorials, courses, consultants embedded in the team? So basically, how did you get the team, the big team participants to grow their understanding of Capella and the diagram that you provided?
Yeah, the best experience we made is that, this was me at this point in time, that we have consultants, internal consultants working in the bid team. So it was a good starting point for me to provide my knowledge and to put it into the bid team, how to share Capella. We did some courses, some small trainings in the background, surely too, that people get a little bit more knowledge about the methodology, about Arcadia and the and the usage of Capella. But at the end, I would say the main advantage and the main point was that consultants like me were working in the bid team and helped to start the bid team to get on board.
Okay. Second question from the same person. How much evaluation of other tools did you do? Like, for example, Nomagic, Cameo, Modelio, and so on.
I would say, and this is my honest answer, we didn't do any specific analysis. Yeah. On one hand, for Thales, Capella is surely the #1 modeling tool because it's coming from our company. We have a lot of support inside it. I take privately at some conference a look at the other tools, and I saw also some advantages they have, but we do not do some deep analysis here for this purpose because Capella is set on one side in Thales, and from my perspective, the advantage that we use only one tool there and do not change it in every bid project covers more than some things which might not be so good like in other tools. But on the other hand, we have many people who work also with other, also often software modeling tools like Enterprise Architect, like Rhapsody, who say at the end, oh, Capella is not so bad as we saw it at the beginning. We start to like it.
Okay. And third question, still from the same person. The question is pretty wide. Can you explain the Arcadia method? So I'm not going to ask you to explain the whole method. We've had several webinars on this topic, and I will provide links afterwards. But we can turn the question is regarding the usage in the bid. What strengths did you see in the Arcadia method? So what are the things in the Arcadia method that for you were the most important in this context?
Yeah, I mentioned it already a little bit during the presentation. We often do not have the time to make a full functional breakdown, to have a look at the full functions there. But where Arcadia helps is is exactly the structure and the 4 levels. So if you want to model something, it clearly helps you to see if you are on an operational need analysis level, on a system need analysis level, on a logical architecture, on a physical architecture level. So during a bid phase where you have relatively rough ideas how the system might look like at the end, it helps you explicitly to structure these ideas, to say, okay, this is a black box, this should be better placed in the black box view of the system, to strongly define what is inside, what is outside the system, and it helps especially to strongly separate logical architecture principles and problems there and physical architecture problems, and to identify missing things in both architectures. So you had, for example, subsystems on a logical figure there and saw, oh, we had forgot to put this in the physical architecture. So we forgot physical devices, which at the end result in missing hardware, and this is surely something you want to avoid, that you later on in the realization phase of a project detect, oh, you have something forgotten there. So this is what, from my point of view, the strong separation and the strong principle to have these 4 different levels helps a lot of a good structure of your architecture also in this phase.
Yeah. There was a related question that was basically you could do this whole modeling with any CDML tool, and the question was what was the added value of using Capella?
Yeah, exactly.
I would say that you did answer that through answering to the Arcadia question. So basically exactly. what you found was a methodological support.
Yeah.
On the question, did you create relationship between requirements for example, coming from redecessor, and did you present them to the team or the customer? Did you have a strategy for requirements?
Yeah, first, I have to answer, but these are two different questions. During the bid phase, we didn't do this because this was not much time to do it there. Yeah, we only have to provide some detailed explanation concerning some requirements where the customer wants to have exactly the way how we want to solve this, and therefore we use Capella as a modeling tool to provide those answers. The linking between requirements and the modeling, we start now in the project phase. So we do it there. We import the requirements into our framework, and we do a linkage via the recif between the requirement there and the functions in the model, but not during the bid phase because of the lack of time.
Okay. How long will the implementation phase be?
We expect for this project an implementation phase of 2 years.
Okay. Two questions were related to the co-engineering activities or collaborative activities. Did you use the team for Capella solution or Melody Advanced inside Thales? So basically the concurrent model editing solution that is provided on top of Capella?
Mm-hmm. We started to use it during the bid phase, but we didn't use it very often. This changes now in the implementation phase, where we currently use the team variant because we are much more system architects now working in cooperation on the same model.
And well, there was one related question that was for the co-engineering activities, like, did you have to manage multi-site?
Mm-hmm. Not during the bid phase. There it was very simple because the bid team was located at only one location. But now during the implementation phase, we have exactly this problem because the development teams were spread over Canada, Portugal, Germany, and Romania.
Okay, so that's interesting. There's a question that is kind of related to that. The question is, what approach have you used to derive lower-level artifacts, for example, XML or UML, that can be used at the developer level? So basically, the question is, in the past, but given that the implementation is only going to start or is starting, you can take that this question as, what will be your strategy to derive lower-level artifacts, the ones that are going to be developed in Portugal and other places?
This is a good question because we have to cope there two different perspectives. Yeah. Currently, our developers are used to get requirements from our part of system engineering that have been broken down, split up from the customer requirements to their subsystem. And what we are doing now, we are using Melody and Capella and the logical and physical architecture to do the functional breakdown and to allocate to each component these functions they have to implement. So they get these functions as the basic input, and they set up their design now on the software architecture on base of these functions, on this functional change we provide there to them, and to give this as an input to them. So some teams are just discussing if they model it then also in an own Capella model there. Some other teams which are more experienced in existing products like Enterprise Architect or other UML tools may use this. Especially some teams want to do code generation at the end, which is sometimes more efficient in different tools.
Okay.
So the functional definitions are the clear interface between the two systems.
Another interesting question, knowing your context. the question is, are you modeling also a generic solution and find deltas between the bid model and the generic solution?
Mm-hmm. Yeah, this is a very, very good question, because this is the basic idea we had with the reference architecture you, Stefan, already mentioned in the introduction there. So we try to do this, but this is currently quite difficult for us, because we develop a new approach with a new architectural structure there, not based on existing project, but on a new componentized approach there. So we try to do this and try also to incorporate ideas like product line engineering to say, and to use this to instrument this model there. But there we are also on the first steps to introduce. But we have this in our mind when we try to set up the model.
Okay. One other question is, when did you start using Capella? I don't know whether it's a personal usage of Capella, or when in the bid phase did you start, like right from the beginning or after some time? Like, I let you answer that.
Yeah, I think the later answer is the more interesting. I started to use Capella, I think, 4 or 5 years ago, but it was interesting. It was in the middle of the bid phase, yeah? The bid phase was, I think, also 2 years, and they did 1 year working without Capella, and in the middle of the bid phase, where some of the problems have been discovered, I mentioned before, we introduced Capella. So I would say the last 1 year of the bid phase, we use it.
Okay. I will ask Camille to unmute the participants, so that if anybody has 1 or 2 more questions, they can directly ask them. So you are unmuted now, so don't hesitate to ask 1 or 2 more questions directly to Michael. Okay, no specific questions, no additional questions. We already had quite a bit. That was really interesting.
We have a question.
Okay, go ahead.
Okay. What confuses me about when we look at some of these diagrams, and let's call them like a hello world version of trying to get an understanding of the tool and stuff. How does this really work when the complexity of the system being modeled is considered very complex and very high and very large?
Mm-hmm. So, from my point of view, Capella has the advantage to model both sides. So you can do in one model, especially due to the different levels there. Also, the approach that you have on one side, a view with some figures, I would say it's something like a management or a bid view there, which abstracts a lot of the information. For example, in the figures I showed before, inside these blue boxes, there are a lot of more components inside, which are defined there with their basic functionality. So, but I can abstract this and show only figures showing the basic architecture for I would say a more management or bid-related documentation there. But the main advantage is I can then go down to one place, to one critical place there, inside the model, and show detailed behavior at this component in a much more detail. But I have it in one model, and this is one of the major advantages I see there. Because if I rename then one component in the detailed model, I also have it renamed in the much more abstract model. And also one thing I would want to add there. Even if this looks much more like a Hello World model, you're right there, yeah? but sometimes it helps also in relatively easy things like a bit phase, for example, to use Capella. And I want to encourage you to do it not only for complex models, but to use it also for much more simple things and much more easy approaches there, because it helps sometimes there too to model all such easy things, because not all easy things are always in the same mind in the head of the people.
Michael, I have one question related to that. In your logical or physical architecture, how many components or how many functions are you talking about?
Functions, not so many, because we didn't have the time to do the breakdown. I would expect that there are 20 or 30 functions only modeled. Components, we have much more. I would expect that we have modeled about 50 to 70 components there.
Okay.
This was not visible on my slides here, but in the model they are surely.
Okay. I think we'll stop with the questions and let someone ask the last one.
I have a question.
Yeah.
Is the cost for the bid being calculated directly from the model using some specialized viewpoint?
This would be a good idea. No, it was not just in this moment, but for one of the next bits, for example, especially on the hardware, it would be maybe a good idea to do this. No, we didn't do it there, but I would say this would be a good approach for the next bit.
Okay. Michael, can you promote me as a presenter?
Okay, I will try.
So thank you, Michael, for a very interesting talk, and thank you for the very precise answers you provided to the different questions that were asked. You can vote for the topic of the next webinar. So there's a link here. You can choose or give your opinion regarding the next webinar topic. You can get the slides of this webinar, and more importantly, give us your feedbacks. So please go vote and connect after the webinar and give us your opinion. A few announcements, what's coming in the next few weeks or months. There will be the EclipseCon event in France, in Toulouse. There will be a Capella workshop in the afternoon of June 12th, so everybody is welcome to come and participate. There should be, but it still has to be confirmed, a sponsored talk in the conference, in the main conference. And there will be an OBO booth with possible Capella demos still on in the EclipseCon. The next conference is going to be the INCOSE Symposium in Washington, D.C. There we will have a booth during the 3 or 4 days of the conference, and we'll be able to provide a lot of demos and answer questions and have discussions on Arcadia and Capella and so on. There will also be a talk about the usage of Capella for nuclear power plant engineering by Juan Navas, and that's it for the next 2 major events. As usual, the different links for Capella. First of all, the website. We strongly invite you to subscribe to the LinkedIn discussion group, where we usually post quite a bit of information. And then if you want to know more about Arcadia and Capella and ask questions, usually the answers come pretty quickly, so use the forums, and here are the addresses. So thank you very much for participating, and see you at the next webinar. Thank you. Bye. The session will now be closed.